Okay, so this is the review, and these are the 3 questions from the review. The first one says, use the analytical method. I'm going to go ahead and put this right over here for me. It says, a force of 42 newtons is exerted on another object toward the south. Another force of 28 newtons acts on the object toward the west. Describe the resultant force. Okay, so let's see. 42 newtons exerted toward the south. South is down. So I'm going to go ahead and call it 42. If 42 newton is exerted on the object toward the south, this is 42 newtons.
Excuse
Dang.
this brief interruption. All students that did not get
Another force of 28 newtons acts on the object toward the west, and I'm adding it. I'm not adding it here. I'm adding it here because it has to be head to tail.
Staff and they will help you. Again, if you're a Cardinal student today and you did not get a sticker on your card or stickers on your card, you're not in the period.
So describe the resultant force. Basically, what is the resultant force? It's gonna be right there. That 42 goes over here. I was like trying to figure out which side to put it on. Okay, so this is pretty easy. We're just gonna use Stag's theorem. So C equals the square root of A squared plus B squared C, which is the resultant. This is A plus B, or A plus B equals C. So square root of 42 squared plus 28 squared, and you get, I'm gonna get 50.5. Okay, I'm just gonna call it 50. Keep it simple. 50 newtons. So that's this, 50 newtons. Okay, but that's not enough. This is a vector with direction and magnitude and direction. So I'm gonna go ahead. This is gonna be like my north, east, south, and west. All right, because this is at the origin. And let me just make sure. So 42 newtons south and 20 newtons west. Everything makes sense. So we need to figure out what this is gonna be. Well, this is 180. Oh, sorry, I can't do it like that. Wrong, Miss Moore, wrong. You want to figure out what this angle is going to be. And so in order to do that, we need to use our tangent because we have opposite and adjacent. So the tangent of theta equals opposite over adjacent. Okay, and I want to get the angle, so I'm going to say theta equals tangent -1 of my opposite, which is 28, over my adjacent, which is 42. Divided by 42, and I get 33.69. I'm just going to call it 34. 34 degrees. So this right here is 34 degrees. However, this is what I was talking about. We need to know what the whole thing is. So if this is this is 34 and this is 180, I'm gonna do 180 plus 34, 180 plus 34, and I get 214. So it's 50 newtons at 214 degrees. That's for number 1. Done. Okay, number 2. You pull a wagon with a force of 223 newtons. The handle makes an angle of that with the horizontal. How much force vertically, horizontally? Okay. Right. So again, I usually start with my northeast, southwest. So it says you pull a wagon with a force of 223 newtons. So we're going to call this 223 newtons. And it makes an angle of 48 degrees with the ground, with the horizontal. How much force? Because it pulls both this way and this way, right? So we want to know how much force there is being pulled. Sorry, I should have drawn it like this first. We got them head to tail. Here and here. Okay, so let's figure this out. So we can say that the vertical, which is my, my horizontal, which is my green one, is going to be the hypotenuse, 223, times the is adjacent, so cosine of 48. And this one's going to be 223 times the sine, because it's the opposite of 48. Sorry for the announcements, you guys. Okay, so this one's going to be, we'll call it 149. And then this one's going to be 223 times the sine of 48, which is 166, we'll call it. And those numbers make sense. Newtons. Okay, great. Awesome. Moving right along here. And that was for this one here, vector resolution. So vector resolution, we use the sine and the cosine to figure out the parts. For the analytical method, we used Dag's theorem and then the inverse tangent, and then we had to resolve it, by adding, when I say resolve, I mean this part right here in order to get that 214. Okay. Last one. This is a challenge question. So let's go ahead and start working on this. Ball rolls 5.3 meters down a roof at an angle of 45 below the horizontal, then falls 2.5 meters to the ground. What is the vertical displacement on the roof, and what is the total vertical displacement? Vertical is up and down. So let's go ahead and draw this. Space, there we go. Okay, so I always start with this. Here we go. So a ball rolls 5.3 meters down at an angle of 45 below. So it's going to be down 45 meters, 45 degrees below the horizontal. So this is like the roof of the house. Like if my house was like, right here, roof. That kind of thing. Okay. And then it falls. Then falls, so 2.5 meters to the ground. So this is 2.5 meters. Again, this is vertical up and down. And it wants to know and then this is right here, from here to here is 5.3 meters. So it wants to know, what is a vertical displacement on the roof? So that's just this part right here. In the past, we've calculated the horizontal and the vertical. Right now, we only want the vertical right here. So from here to here, that's a triangle part. That's easy. So it's the opposite, and that's the hypotenuse. So my displacement in the y direction is going to be 5.3 times the sine, because it's the opposite, of 45. So the hardest part here is just a diagram, really. Times the sine of 45. Oops, whoops. Times 5.3 times the sine of 45, and I get 3.75, we'll say, meters. So that's from here to here, 3.75, and then from here to here is 2.5. So we can just do 3.75 meters plus 2.5 meters. 3.75 plus 2.5 gets me 6.25 meters. Okay. Boom. So, what was the vertical displacement of the roof? Vertical displacement for letter A was 3.75. That's this part right here. Letter B, what was the total vertical displacement? It's this displacement plus this displacement, which gets me this. All right.